Okay, this is the design assignment video for design assignment 3A, UART communication using the Atmega 328P. All right, just a moment ago you saw the schematic that I'd set up, basically implementing the FTDI chip. It's basically a breakout board that helps us to convert between TTL to RS-232. In other words, we're basically able to break down so the board can communicate through USB to the computer easily. In this case, what I've done, let me just walk through the code. I kind of showed it, basically walked and showed it through before. I'm going to go ahead and stop this for the moment I started. But basically, what we do is we set up a couple of different things. Importantly is the baud rate, which is to be used by both the master and the slave, in connection one to another, right? So they can operate asynchronously. It's used for the prescaler, and then here we set up a couple of different numbers, and then use a timer. Right? We basically use the timer from 2C to be able to create the delay that's desired. So anyway, long story short, the important thing here is that obviously we set up a few things for the timer here, but importantly we're able to set up and initialize the baud rate on the device with respect to the clock and things like that. So, and then we're able to print to the serial port using a couple of simple commands. In this case, if we have a string, we're able to just throw it into this command line, UART tx string, and it drops it right into the COM port. So what this basically does is print my desired values, right? The first one being simply a string. In this case, it's sup, S-U-P, whatever, three ASCII characters, and then prints an empty space behind it, right? Next one, a random integer. I found out today it doesn't actually have to be a random number. It could just be an integer of any choice. But nevertheless, I ended up writing into this simple function in C code. Just jumps out a random number, using a seed. So provides me a random integer, but I have to convert that random integer to correctly print it as a string. So I use this function, snprintf, which Dr. Venke had showed us on the code. So it's able to, in other words, I can dump my number here, gets turned into a string in outs, then I just print outs and then print another space behind it so it doesn't, next number. Same thing. In this case, I just called her number, right? At this point, I'm just making up variable names as I go along. So basically, I'm able to do a similar thing with a float number, right? So her number, which is a float declared up here, 27.36534442500003, super long length float number, can be taken and dumped inside this function called sprintf, and it gives me a string in outs again in this case, and dumps it into here like so. Okay, same thing, prints it out. What we'll notice is interesting is it doesn't print all of, in other words, it doesn't provide all the significant digits. It only provides, I think, 7 or so. And I still can't figure out why or how to change the length of that print, or the length of that comes out. So, so for our delay, calculated a value that equates to 1 second. It relates to how many times an overflow occurs, respective to starting my compare. I use CTC mode to 220, right, at timer 0. So, okay, these are just some stuff from before. So initializing, and incrementing and printing. So, can we start that? We'll use the data visualizer to be able to view what's going on in the port. What's interesting is you can actually use a virtual port, meaning because we have the embedded debugger, we could look in the serial port and see the information is being dumped and being printed. But obviously, we want to use the FTDI chip, so I'm going to go ahead and do that now. Okay, and this is what our stuff looks like, as you saw some of the pictures. Basically, we've got the board hooked up, the RxTX pins. It provides power to the FTDI chip. It's kind of dark. I'm sorry, it's late. But here's the chip being plugged in there. And then as well, I just jumped in my USB logic analyzer in behind it. Just to look at the prints going on over time. I'm going to show a quick scan in here in a second. So, okay. All right, so it's connected to that port. I've already hit start, so we should be able to just jump it up and we'll be able to see it. And sure can, okay. sup, a random number, and then 27. Like I said, it only prints 7 characters, right? The 7th being actually the dot, right? This represents an actual character as well when it's printed into a string. This is probably interesting too, is you can actually show that. You look at the timestamp, right? So as everything's printed, it really tells you that at this moment, the instance, this is printed as well. So, okay. In connection to that, we can go ahead and throw the logic analyzer on. We can see, go on. I'm gonna go ahead and print this for 10 seconds. And this sample rate, good. Start. Take us a second to run around and get that to actually see it. Here on channel 0. Let's see. Okay. And there we go. Look at that. So this is kind of cool. You can zoom in to what I would call the word, right? The word being all of them occurring, right? And this is each of them going on. Pretty interesting to see, right? So, okay. And that's it. That's the design assignment 3A. I probably could have chose a better word.